Example 2.1, determine the power absorbed by each of the resistors in the circuit. So you can see here that we have a 3-loop circuit. And what we want to do here is that we want to use simple ideas of how to determine as many of the node voltages as possible, and also determining when series and parallel. So here's my typical thinking. 1, use different colors to identify all nodes. And then from there, look for what is in series versus parallel. And then the goal of the problem here is that we want to calculate the power absorbed by all resistors. So when you look at the circuit, you could see that there's 3 resistors. So we want the power of the 8 ohm, we want the power of the 6 ohm, and we want the power of the 4 ohm. So what I'm going to do now is that I'm going to come in and I'm going to look at the circuit. And here's the circuit right here. And so now I'm going to start coloring things. So if I start coloring things, what am I seeing here? Well, I have to define a ground. It's arbitrary where you choose it. So the way I'm going to choose it here is I'm going to choose my ground right here. So that means here is that this guy is my 0 volt. Now, when you look at that 8 volt, note that from the ground all the way to above that 8 volt, that means here that that's 2 equipotentials with 1 source, so that guy has to be 8 volts. So that means I've identified one of the node voltages here. Now let's continue moving around here. So now what this tells me here is that I know that the voltage of the red node has to be 8 volts. Now the next one that I want to do here is that I'm going to look at this next node right here. And what's important about this node, note that that 12 volt is connected to that 0 volt source. So that means here that as I go from the ground to this blue node, note that the positive is connected to the ground. So you're actually going down. So in this case, the 0 volt is at a high voltage, and this blue node is at a low voltage, and it has to go down by what? Minus 12 volts. So one of the things that I should have done with the red node, to be a voltage, you have to have differences in potentials. So you could see that's how I got that. So now if I look at the blue node, this here, the high is 0. And then as I'm going down, it has to be negative 12 volts. So there's a difference of negative 12 volts. So I went down. Now, if I look at this guy, I now have another node here. And this node here, I'm going to color green. Now let's look at this loop here that we're going to look at. So if I follow my path, look how I'm going to follow my path. I'm going to start here at ground. So if I come up here, you could see that I increased my voltage from minus to positive. We know that's an active source, so it adds energy to the circuit. So if I continue along this purple path, Now look what happens. When I get to right here, note that they have opposite polarity. So as I come up here, I'm going to go down 8 volts. So I increase by 8, and then I decrease by 8. So now if I look at the voltage of the green, that means I increase this thing by 8, and then I decrease it by 8. So therefore, that voltage is 0. In other words, this guy is actually a ground as well. It's 0 volts. So note, I now know the voltages across the 8 ohm and the 6 ohm. So let's go look at that. So for starters here, you could see that if I focus on the, let's say that I say the red node, right? So if I just color code this to try to be a little bit more transparent, this tells me here that the voltage of the red, this guy is 8 volts. So I now know what the voltage is. So that means these two must be in parallel. So if they're in parallel, that means then that the voltage of the 8 volt source has to be the same as the voltage as the 8 ohm, which now has to be 8 volts. So then the power of the 8 ohm is then has to be the voltage of the 8 ohm squared divided by the resistance of the 8 ohm. And you can see that this guy is going to be 8 squared divided by 8, which will then gives me 8 watts of power for the 8 ohm resistor. So I've now calculated the power. And note, all I did here was just follow my lines. Now let's focus on the 6 ohm resistor. So you could see here is that if I look at the 6 ohm resistor, note that I know the voltage across that 6 ohm resistor. So what I'm seeing here is that the high is the 0 volt. The negative 12 is the lower voltage. So if I focus on the blue node now, we then see that the voltage across the 6 ohm should be 0 minus 12 volts. So in other words, its voltage is negative 12 volts. So that then tells me then that the power of the 6 ohm then has to be, again, the voltage of the 6 ohm squared divided by the 6 ohm resistor, which is then going to give me 12 squared divided by 6. That turns out to be positive 24 watts for the power of the 6 ohm. So you could see that I'm just focusing on getting those node voltages. Now, what we want to do here is that now we want to look at the left loop. And if you look at the left loop, what you're seeing here is that note that the 2 amp source, the 6 volt source, and the 4 ohm are all in series. And if they're in series, that means here is that they have the same current. In other words, that means that the current of the 2 amp must be the same as the current of the 6 volt, which must be the same as the current of the 4 ohm, which has to be 2 amps. So now I can use the power. So then the power, so I now know what the current is. So then the power of the 4 ohm has to be the current of the 4 ohm squared times the resistance of the 4 ohm. And if I look at that, that's going to give me what? It's going to give me 2 squared times 4, which will give me positive 16 watts for the power of the 4 ohm.